Robin Hood Radio presents Your Health with osteopathic physician Dr. Kim Tripp, a show presented monthly on Robin Hood Radio, discussing the challenges faced and the solutions that are available for keeping vital health and well-being throughout our lives. And now, here's Dr. Tripp.
Hello, everyone. Welcome to Your Health with Dr. Kim Tripp, osteopathic physician. This is the health show created to bring you vital information and discussion of all kinds of health issues from the unique perspective of traditional osteopathic medicine. So first, let's clarify what osteopathic medicine means. Osteopathic medicine is practiced by fully licensed physicians in the U.S. with a DO degree, a Doctor of Osteopathic Medicine degree. Our practice is based on the essential relationship in all living things between structure and function. In other words, the natural interdependence between anatomy and physiology, or that between the physics of the body and its chemistry. As osteopathic physicians, we use our comprehensive and precisely detailed knowledge of anatomy and physiology to promote health and healing in our patients. We work gently with our hands to help your body restore optimal function based on optimal structure. Our medical specialty is therefore called osteopathic manual medicine. We receive uniquely in-depth training in anatomy and physiology and their relationship within your body in the context of a full physician's medical training. Only U.S.-trained osteopaths are fully licensed physicians and have all of the current medical pharmacopoeia, nutritional science, and full medical training at our disposal. This means that your individual treatment may include a wide range of approaches, but it will always be founded on our gentle hands-on work. We practice from the unique perspective of first looking for the health in our patients rather than merely finding illness and disease. Our practice has been especially effective for, but is not limited to, musculoskeletal and other structural problems, as well as things like chronic headache, gastrointestinal issues, post-concussive syndrome, sleep disturbance, and many other health problems. We work together with you, the patient, to help you build health and vitality in your body, mind, and spirit as the solution for your health problems, rather than only treating the disease symptoms. So in the radio show, we tackle health issues from this point of view. What can we do to help you build your health and vitality in order to prevent and heal injuries and disease? And we do that by giving you some basic information about the problem, to help you understand what is happening, as well as offer solutions and guidance for helping yourself to heal and stay healthy based on our clinical experience with patients in our practice. We are now midway through our series on the human immune system, and we're going to do a bit of review to start, as we always do in series of shows. However, we can't do a full review at this time, or I won't have time for any new material. So before we get started on today's topic, let me alert you that this is very dense material. It's very complicated. There's a huge amount of information. I've done my best to distill it down to a reasonable radio show, but this gives me the opportunity to remind you that you can listen to all of the Your Health shows online at your convenience, including today, again, if you want, by going to the Goldman Tripp website, www.goldmantripp.net. Click on the radio show icon, then scroll down and click on the individual show by topic. There are now nearly 50 shows available. You can also get the most recent podcasts, including the last 3 immune shows, on the Robin Hood Radio website itself in the on-demand section. So no excuses for not getting the material down. Okay, let's get started. The immune system is clearly on everyone's mind right now in the context of this current pandemic. The human immune system is a highly complex system of interactive organs, tissues, and specialized cells that serve to protect the entire body from foreign substances and toxins, from invading microbes like bacteria, fungi, and viruses, and from our own cells gone awry, by producing the immune response. The immune response is a multi-layered biology that ultimately uses many different normal cells, tissues, organs, and physiological strategies within our own body to clear these problematic substances, invaders, or abnormal cells from the body. I do want to reiterate that normal immune system development and function rely on one basic biological principle. That is, the ability of the immune system to recognize substances, organisms, and cells that are in or on the body as being either self or other, and then to respond with the appropriate physiological interaction with that substance, organism, or cell. It sounds simple, but in order to function successfully, that simple biological principle must be manifested as a nearly infinite array of sensing and response mechanisms throughout our entire life, starting in utero and adapting and evolving through birth, infancy, childhood, adulthood, and old age. So today we'll continue our exploration of that miraculous system, and we'll delve into the details much more deeply as we work through the whole series. Remember, as we dive into this discussion, that the immune system has the complex task of recognizing what belongs to the self and what is other, and then deciding whether or not the so-called foreign material or microbe is harmful or possibly even beneficial. Not all microbes are harmful. Remember, we have an enormous microflora of thousands of kinds of diverse bacteria and yeasts that are meant to live in various parts of our body in appropriate relative proportion to each other. So not too much of this one and not too much of that one. And to keep within their appropriate location, colon versus eyelid, for example. And the immune system has to be able to recognize all of that and help keep it in balance. So, again, here's a brief review. There are two basic systems of immune defensive response: innate and adaptive. The innate system, which we've already covered, is a kind of rapid first responder with generalized responses to all intruders and abnormal cells, including the basic inflammation response. The adaptive system takes longer to respond as it provides specific antibodies and defenses tailored to the specific intruder. The adaptive system is activated by the innate system. It is the adaptive system that we will tackle today. Both systems exist to defend us from potentially damaging organisms, collectively called pathogens, referring to their capacity to generate pathology, i.e. disease, as well as harmful foreign materials and toxins. Both the innate and adaptive immune systems work together in an interdependent approach to dealing with pathogens. Pathogens directly activate innate immune responses against infection in all multicellular organisms. In vertebrates, though, pathogens and the innate immune responses they cause stimulate adaptive immune responses, which then help fight the infection with more specifically targeted defenses than the innate system can offer on its own. The innate system is therefore more generalized and faster to respond. The adaptive system generates specific responses to recognized entities and therefore is more targeted, but also therefore takes longer to mount a response. The innate system, once activated, catalyzes the activation of the adaptive system. Adaptive immune responses are slow to develop on first exposure to a new pathogen. It can take a week or so before their responses are effective. By contrast, pathogens can create problems much more rapidly than the adaptive immune response can get up and running. For example, certain types of bacteria can produce almost 20 million offspring in 1 hour from one single bacterium, creating a rampant infection in one day. Therefore, during those first crucial hours and days of exposure to a new pathogen, we rely fully on our innate immune system to defend us. That innate immune response is well named, as it refers to the set of immune responses you are able to use shortly after birth. Innate immune responses are not targeted to a particular pathogen in the way that the adaptive immune responses are. In the last show, we discussed the crucially integrated component of the innate immune response, that is the inflammation response. The innate system's partner is this adaptive immune system, or it's sometimes called the acquired immune system. The adaptive system has a very different strategy for dealing with pathogens than our innate system. This adaptive system arose early in vertebrate evolution. It actually first appeared in the earliest jawed vertebrates. In humans, the adaptive or acquired immune response takes days or even weeks to become established. much longer than that innate response. However, adaptive immunity is more specific to the individual pathogens and has memory about what pathogens it has seen and quelled. Adaptive immunity is an immunity that occurs after exposure to an antigen. Recall that an antigen is a physical or chemical aspect of a pathogen that stimulates our immune response. The antigen can come from either the pathogen or a vaccination. We'll have a lot more on vaccination mechanisms in a future show. This part of the immune system becomes activated when the innate immune response has not controlled an infection. And without the information from the innate immune system, the adaptive response could not be mounted. The innate immune system contains cells that detect potentially harmful antigens and then inform the adaptive immune response about the presence of these antigens. There are two types of adaptive responses engineered by the white blood cells that we call B cells and T cells. The cell-mediated immune response, which is implemented by T cells, and the humoral immune response, which is controlled by activated B cells and antibodies. Activated T cells and B cells that are specific responders to specific recognized structures on the pathogen proliferate and attack that invading pathogen. Their attack can either kill or neutralize the pathogens directly, or they can stimulate secretion of antibodies that enhance the phagocytosis of the pathogens. Remember that cellular eating up of pathogens, and disrupt the infection. Adaptive immunity also develops and relies on an antigen memory to provide us with long-term protection from reinfection with the same type of pathogen. On re-exposure, this antigen memory will stimulate an efficient and faster response than the initial response. This all sounds pretty straightforward, but it's actually a multifaceted and very complex process with many layers of physiological feedback and interactive loops, which we can't detail in the setting of this show. However, here's one example of what I mean with regard to T cells. There are three types of T cells: cytotoxic, sometimes called T killer cells, helper, and suppressor T cells. Cytotoxic T cells destroy virus-infected cells in the cell-mediated immune response. And helper T cells play a part in activating both the antibody and the cell-mediated immune responses. Suppressor T cells deactivate T cells and B cells when needed and thus prevent the immune response from becoming overreactive and creating disease. T and B cells only have one type of antigen receptor and therefore are super specialists that recognize and act on only one type of antigen. As an individual person grows and matures and develops their library of T and B cells, they may have a population of T and B cells that together express a nearly infinite variety of antigen receptors that are capable of recognizing virtually any infecting pathogen. T and B cells are activated when they recognize small components of antigens called epitopes presented to them by specialized presenting cells of that innate immune system. In the absence of information from these innate system cells, T and B cells remain inactive, or naive, we call them, and are unable to prepare or mount their specific immune response. The requirement for information from the specialized presenting cells of innate immunity to trigger B cell or T cell activation illustrates the essential nature of the innate immune response to the functioning of the entire immune system. The adaptive immune system expresses a memory function that allows for an efficient and dramatic response to reinvasion by a pathogen it has already encountered. Memory is handled by the adaptive immune system with little reliance on cues from the innate response. During the adaptive immune response to a new pathogen that has not been encountered before, called a primary response, naive populations of B and T cells are learning to respond to the new pathogen and becoming active in attacking that pathogen during this process. Subsets of these activating T and B cells then differentiate into so-called B and T memory cells with the same antigen specificities. A memory cell is an antigen-specific B or T cell that does not differentiate into an active attacking cell during that primary immune response, but it can immediately become an active cell upon re-exposure to the same pathogen. During the primary immune response, memory cells do not respond to antigens and do not contribute to host defenses. As the infection is cleared and pathogenic stimuli subside, the effectors are no longer needed, and they undergo apoptosis, which is a kind of spontaneous self-induced death. In contrast, those memory cells persist in the circulation and are ready to be activated if that pathogen is encountered again. If the pathogen is never encountered again during the individual's lifetime, B and T memory cells will circulate for a few years or even several decades and will gradually die off, having never functioned as activated cells. However, if the person is re-exposed to the same pathogen type, circulating memory cells will immediately differentiate into activated cells. One reason the adaptive immune response is delayed is because it takes time for naive B and T cells with the appropriate antigen specificities to be identified and activated. Upon reinfection, this step can be skipped due to the memory cells, which become immediately activated. And the result is a much faster production of immune defenses. This rapid and dramatic response may stop the infection before it can even become symptomatic, and the person may not even know that they had been exposed. So where do these crucial immune cells come from, and where do they go to do their work? In general, the cells of the immune system originate from what we call hematopoietic stem cells in the bone marrow. Cytokines stimulate these stem cells to differentiate into immune cells. B cell maturation occurs in the bone marrow itself, whereas naive T cells migrate from the bone marrow to the thymus gland for maturation and regulation. This process helps prevent autoimmune responses. On maturation, T and B cells circulate through the body to various destinations via the blood and lymph. Our lymph nodes, which are scattered throughout the body, house large populations of T and B cells, dendritic cells, and macrophages. Lymph gathers antigens as it drains from tissues. These antigens are then filtered through the lymph nodes before the lymph is returned to the general circulation. Innate system presenting cells in the lymph nodes capture and process antigens and inform nearby white blood cells about potential pathogens. Cells of the immune system can travel between the lymphatic and blood circulatory systems by a process called extravasation, which means leaving a vessel and passing into surrounding tissue. This is all a good reminder about the crucial nature of our lymphatic system with regard to immune function. And again, this all sounds quite straightforward, but it is extremely complex and really rather miraculous. Which brings me back to osteopathy and to the close of today's show here on the adaptive aspect of our immune system with a reminder that an osteopathic physician who is a specialist in osteopathic manual medicine can be very helpful for immune issues of all kinds. Working gently with our hands with the involved organs, nerves, vasculature, fascias, capsules, and associated tissues to release restrictions in the physical tissues of the immune organs, the lymphatic system, the diaphragm, chest, and blood flow, as well as to help balance the autonomic nervous system function based on anatomical detail, and to help with nutritional issues and support for whatever procedures or treatments you may be going through. Recall that all of the immune system is a complex physical entity with connections between all the parts that need to be open, flexible, and moving freely, with excellent neural conduction from the nerves, optimal arterial and venous blood flow, and lymphatic drainage to remain healthy, vital, and functioning normally. Well, that was a lot of material, and I've used up all the time. Remember, you can review all these things by listening to the shows on the websites. Meanwhile, thank you for your attention to Your Health with Dr. Kim Tripp. Remember, you can email your comments and suggestions for topics to yourhealth@robinhoodradio.com. If you have a health issue yourself and you'd like to find out about how we might be able to help you in our practice of traditional osteopathy, we're at our offices in Sharon, Connecticut, Dr. Kim Tripp and Dr. Andrew Goldman. Goldman Tripp, Osteopathic Healthcare, 860-364-5990, with evening hours Wednesdays and Fridays. On the web at www.goldmantripp.net. I'll look forward to being with you next time. Till then, you take care of yourself, enjoy your health, and thank you for listening.